Look down at your hand right now. A ring, a watch, a phone with metal inside it. None of that existed for your ancestors. Not for 99% of human history. For thousands of generations, the only metal a human being would ever touch fell out of the sky. In 1911, archaeologists dug into a grave in Egypt. A person buried more than 5,000 years ago, wearing a necklace strung with gold, lapis lazuli, and 9 strange little tubular beads. Nobody thought much of them. They looked like scrap metal, and for almost 100 years they sat in a drawer, unexamined. Then, in 2013, scientists finally scanned them. X-rays, neutron activation analysis. What they found should not have been possible. The beads weren't bronze, weren't copper. They were iron, packed with nickel, cobalt, and a trace element called germanium, in a ratio that doesn't exist anywhere in the rock beneath your feet. That ratio exists in exactly one place, the shattered core of a dead planet, torn apart millions of years ago, drifting through space until a fragment of it hit Earth. Your ancestors were wearing meteorites as jewelry. Here's the part that should bother you. It took another 2,000 years before a single human figured out how to pull that same metal out of ordinary ground. Longer than the gap between Julius Caesar and you reading this. So what took so long? Don't picture cavemen. By the time that Egyptian grave was filled, humans had been running furnaces for centuries. They knew how to smelt copper, alloy it with tin to make bronze, melt metal like water, and pour it into a mold. And for tens of thousands of years before that, people had ground up red rock, hematite, iron oxide, and rubbed it on bodies, cave walls, the dead, as pigment. Iron is everywhere. Far more common than copper or gold. It was sitting in human hands for millennia, and never once turned into metal. Why not? Gold and copper sometimes sit in the ground as pure metal. Find a lump, hammer it, done. Iron almost never does that. It's chemically handcuffed to oxygen, locked inside rock. To free it, you have to violently rip the oxygen out, a process called reduction. Reduction needs 2 things at once: heat above roughly 800 degrees Celsius, and an atmosphere almost empty of oxygen, dominated instead by carbon monoxide gas. A campfire cannot do this. An open fire tops out around 600 to 700 degrees, and it's drowning in oxygen. The one thing that ruins the reaction. Any iron that briefly formed would rust itself back into rock before your eyes. So the story you've probably heard, someone accidentally smelting iron cooking dinner on the wrong rocks, is flatly impossible. There was a second trap. Even if you solved the chemistry, iron melts at 1,538 degrees Celsius. No ancient furnace got near that. Bronze workers could liquefy their metal and pour it. Whoever cracked iron would never get that option. 2 locked doors. Both had to open at once. Before either door opened, your ancestors found a loophole. Meteoritic iron skips the chemistry problem completely. It's already pure metal, forged inside a dying planet's core, then cooled for millions of years into a crystal pattern called Widmanstätten structure, a pattern that cannot form on Earth. It's a fingerprint stamped in by deep space itself, which is how scientists can still tell, 5,000 years later, which ancient iron fell from the sky. All a smith had to do was heat the metal and hammer it. Around 3400 BCE, someone in Egypt beat meteorite fragments into beads. By 1350 BCE, Tutankhamun went into his tomb with a meteoritic iron dagger, right before the whole system that made it so rare collapsed. For close to 2,000 years, nearly every scrap of iron on this planet had once been floating in space. Working it taught real skill, but nothing about how to make more of it. Sky Metal solved, how do I shape this? It left, how do I make this completely untouched? The real answer came out of copper. Copper ore usually arrives mixed with quartz, dead rock. To strip it out, smelters added a flux, something that binds to the silica and forms liquid waste you can pour away. One of the best fluxes available was iron oxide, the same red rock ground into pigment for tens of thousands of years, now shoveled into copper furnaces. Nobody was trying to make iron. They were trying to make cleaner copper. But inside that fire, over 1,100 degrees, starved of oxygen, packed with burning charcoal, exactly the conditions an open flame could never reach, something happened that nobody planned. Some of that iron flux got reduced too. Not into slag, but into small, hard nodules of solid metal sitting inside the waste. A smelter cracking open old slag heaps, expecting brittle glass, found these strange, dense lumps instead. Ones that wouldn't melt, wouldn't break. That's the accident. And somebody noticed. Furnace after furnace, generation after generation, the same strange lumps kept turning up. The question stopped being, what is this? And became, how do we make more? More charcoal, taller furnace shafts, adjusted airflow through clay tubes called tuyères. Slowly, an ordinary copper kiln got re-engineered into a furnace built to make iron on purpose. This process is called the bloomery. Layers of charcoal and crushed ore, stacked in a clay shaft. Bellows push air in, keeping the chamber hot and starved of oxygen. Carbon monoxide rises through the ore and tears the oxygen off it. The waste melts off as slag and drips away, but the iron itself never melts. 1,538 degrees is out of reach. Instead, it clumps into a glowing, half-solid mass called a bloom, a rough, spongy lump pulled red-hot out of the fire. This is the moment blacksmithing is actually born. That bloom has to be beaten, hammered over and over, forcing the trapped waste out and welding the scattered iron into something solid. Your ancestors never poured iron into a mold like they did with bronze. They beat it into existence. At Tel Hameh in Jordan, dated to around 930 BCE, archaeologists found a full workshop, furnace walls, mountains of slag, tuyères still in place, iron production running as ordinary infrastructure. The experimenting started centuries earlier. In central Anatolia, at Kalahoyuk, layers dating back to 2800 BCE already contain sintered ore and early carbon steel, made locally. Proof people were quietly testing this, failing, testing again, long before anyone left a written record. Here's what most retellings leave out. When iron smelting finally worked, it did not immediately beat bronze. Early bloomery iron was riddled with trapped waste, softer than good bronze, brutally labor-intensive. Bronze was already mature, castable, predictable. For a long stretch, iron didn't replace bronze because it was better. It sat on the sidelines. So what finally forced the switch? Bronze is copper mixed with tin, and tin had to travel enormous distances across ancient trade routes. Around 1200 BCE, those trade networks collapsed. Political chaos tore through the region. Tin stopped arriving. That's the exact moment the equation flipped. Iron ore, unlike tin, sits almost everywhere. A technology that had spent centuries as a marginal side experiment suddenly became the only option left standing. Not because the metal had improved, but because the alternative had failed. In the Hittite Empire, cuneiform tablets even name iron outright, Habalkinu, pointing to a royal forge at the exact moment the metal stops being rare treasure and starts being something worth controlling for weapons. For decades, the accepted story credited one origin point, Anatolia, the Hittites, one breakthrough radiating outward. The evidence doesn't hold that shape anymore. In India's Ganga Valley, at sites called Raja Nala Ka Tila and Malhar, archaeologists found bloomery furnace debris, slag, tuyères, and forged iron tools beside black and red ware pottery. Radiocarbon dates put that layer at roughly 1880 to 2010 BCE, the same era as the Anatolian material, thousands of kilometers apart, with no contact between them. That's not one idea spreading outward. That's the same accident, happening twice to people who never met. Not every claim survives inspection, though. A site in the Central African Republic once produced dates suggesting iron forging as early as 2000 BCE, but the dig was shallow and likely contaminated. Most archaeologists reject it today. What does hold up? Sub-Saharan Africa developed its own fully independent iron tradition, later clearly dated, visible in cultures like Nok. In what's now Nigeria, iron wasn't discovered once, by one genius, in one place. It was stumbled into more than once by people separated by oceans of distance, chasing the exact same accident inside the exact same kind of furnace. Quick myths cleared up. A meteorite melted straight into tools? No, everyone was forged by hand. Someone stumbled onto iron cooking over a campfire? Physically impossible. Ancient blacksmiths melted and poured iron like bronze? Never. The melting point was out of reach. One civilization invented iron and everyone copied them? Doesn't fit. Anatolia and India were doing this on identical timelines with zero contact. Go back to that grave in Egypt. 9 small beads, strung beside gold and lapis lazuli. The person wearing them had no idea what they actually had around their neck. Not metal pulled from the ground, a fragment of a planet's shattered heart, older than Earth itself, hammered flat by human hands and worn as jewelry 2,000 years before anyone alive knew how to pull that same metal out of ordinary dirt. They thought they were wearing a strange, beautiful stone. They were wearing the opening move of a chain reaction that would eventually reshape how their descendants farmed, fought, and built everything around them. Nobody has found the actual transitional furnace, the hybrid kiln sitting between an ordinary copper flux operation and a true, dedicated bloomery. It's out there somewhere, buried, or long gone. And there's a deeper question that may never get answered. Did the people who first pulled solid iron out of a copper furnace understand, on any level, that it was made of the same substance as the metal falling out of the sky? Nobody knows. Maybe no one ever made that connection at all. 2 separate stories, running in parallel for 2,000 years, that just happened, by accident, to end in the same metal.